Okay, so this is the practice question for this moment distribution method. So this is the questions. You have a pin at point A, B is a fixed join something. You have C, you have D, E, and F. F is fixed, E is a pin. So first step, like I said before, you have to calculate the K. First, step 1, find the K. K is equal to 3EI divided by L if you have a fixed and a far end pin or roller. So you're going to use this. If you have a fixed and a fixed, you're going to use 4EI over L. What is fixed and a fixed? You have a fixed and this point, because they join it together, so you consider it as a fixed. So you're going to have a fixed and fixed. For this one, you're going to have 4EI over L. And for this one, fixed and far end pin and roller, in this case, you have a B, because this is a fixed join. So you consider this as a fixed. So you're going to have a fixed and a far end pin. So you're going to use this for this. So let's start. For K, you know KAB is the same as KAB. So it doesn't matter. So start with KAB. Like I said before, fix and a pin. So fix and a pin, you use this formula. So 3E, in this case, our IAB is 32. So you put 32 over, the length of this is 16 feet. 16 feet. In for this one, you know the E is in PSI, and you know feet is in feet, so you have to convert it into feet square, something feet. Yeah, feet square, and you have I know. Feet times inch to the 4, but you know you're gonna cancel out the numbers, so it had no point to do those things. So just leave it like that. Feet is okay. You don't have to do the conversion. Just leave it like this. And you're gonna have 6E. If you this time this divide by that. And for K, AB we have it, so BC. BC is fixed and fixed. So you're gonna have 4E times the I for BC is 30. So 30 divided by the length is, no, I'm sorry. Yeah, 30 and 30. 30 and 30. So yeah, 30. The length is 30 feet. So this one you're gonna have 4E. And for K, CF, you're gonna have a fixed and fixed. So same one. So you're gonna have 4E times the I for that one is 40. And divided by the length is 20. So you're gonna have AE. And for K, CF, this is K, CD. For CD, wait, CD is CD. You're gonna have fixed and a fixed, so you're gonna use this. So you're gonna have 4 EI. I is 30, and the length of that thing is 24. Divided by 24.
There's no negative positive?
No, K is no positive, negative positive. So you're gonna have. Mohammed, can you do this calculation? Wait, don't tell me move this something wrong in this exam. So let me see.
So you want me to 4 times 30 over 24?
8, right?
5.
5?
4 times 30 over 24, right?
Wait. CD. This is CD, so you're gonna have fixed and fixed. 4 times E times 30 times, oh I'm sorry, it's 30. The length is 30. not 24, 30. So it should be 30, so it should be
4.
4E.
Yeah.
Where I see the 24 come from? Oh, I
I
see.
think you saw the I. No,
Okay,
you can just write it down if you want.
the last one, CD, you're gonna have DE. So K, DE. DE is a fix and a pin, so you're gonna use this one. So 3, E, I is 24,
What's the length?
the length is 12 inch, or 12 feet, so you're gonna have,
6.
yeah, 6E. Alright, we calculate the K. Now move to the distributed factor. Distributed factor is just K divided by the sum of the K at that node. For example, you want to find D, F, BA, BA, B to A. You see this thing? At this node, you have two members, not members, span. This and this. So you want to find BA, you have to sum everything at this point. So you're going to have the K for BA is
6E.
6E. I mean, you can just cancel the E because you know the E is going to be cancelled. You factor out the E. I mean, just one example. I should tell you why you cancel. 6E and the sum of K at this point. So you're going to add this to this. So you're going to have
10.
BA is 6E plus, what about BC? BC.
4.
4. You know you can factor out the E. Big like 6 plus 4E. So E and E cancel, so you don't have to write it. So you're going to have 0.6. The reason why we didn't find a distributing factor for AP is because we're not going to do AP in the table because it's not a fixed end. So the moment at this point is 0. So no point for doing something that has no moment. This is have no moment. That's why we didn't put BA in the table. Same as this one. ED at point D or point E is a pin, no moment. So when we put in the table, the purpose for putting number in the table because we want to find the moment. If there's no moment for this point, there's no point for putting that in. So we just don't do it.
So you add the BFs for
Yeah.
each node?
So distributive factor for BA is this. So for we have BA now, BC. So you're gonna have 4 divided by 6 plus 4, which is 0.4. You know why, right? Because same thing. BC is also at this node. So you have to add this up and then just take this divided by the sum. And for D, B, no. DF, CB, C to B at point C. You're gonna the sum for the sum at point C. You're gonna have this, and this. But do not confuse yourself because we finished calculating the K already. So the I is not necessary. So just erase the I. Just put, and also the feet. The length doesn't make sense. No, I mean, it doesn't matter now. Just erase it. Just put it down like AB is 6. BC is 4. CF is 8. And CD is 4. And this one is 6. So you want to find DFCB. CB at this point. So you're going to add 4 plus 4 plus 8. So you're going to have 4 divided by 4 plus 4 plus 8. You're going to have 0.5. Oh, wait. BC. BC is 0.4. CF. So you want to find CB. Yeah, you're going to have 4 divided by 4 plus 8. So you're going to have 0.25. DF, CF, you're going to have 8 divided by 4 plus 8. So you're going to have 0.5. And for DF, why DF? Oh yeah, distributive factor. CD, you're going to have 4 divided by 4 plus 8. Same as this one.
What about plus 6?
What?
DE?
So now, we also have CD. So now DC. DC is 4 divided by 4 plus 6, which is DC 0.4. Do we have to do E to D?
No.
Why not?
No moment at E. But you
Yeah.
have to do DE.
You have to do DE. So DE is 6 divided by 4 plus 6. So 6 divided by 4 plus 6. 0.6. Now we have all our distributed factors. Step number 3, you have to find the fixed end moment. In this one, I forgot to put the unit load, distributed load. Okay. So in this case, which span is going to have force? There's only one span have the force, which is BC. For this point load, since it's acting at this, the corner of these things, so no span is going to have this force. For this one, is in the same line, so we just lay nothing. And for this one, it's not in between the span, so we don't consider this as the force for this span. So all we have for fixed end moment is BC and CB. So we're going to do that for moment, fixed end moment, for BC. BC, so you have to use your table. And you're going to have, for B to C, you have a distributed, low, and fixed, So according to that, I hope you can see it. You're going to use this table, fixed, and distributed low. So you're going to have this one, because, let me see. B to C is from the left to right, so it's counterclockwise, so it's negative. But from C to B, you're going to have clockwise, so it's positive. So for B, C, you're going to have negative WL squared divided by 12. So you're going to have W is 2, fixed end moment, 2 times negative 2 times L. What is the L?
It's 30.
30.
No, AB is 16. BC
12.
is 30.
So
Yeah.
it's going to be negative 150. Oh, it's cut off. It's equal to negative 150. And for F, fixed end moment at CB, opposite, so become positive. So you're going to have 2 times 30 squared divided by 12. So you have positive 150. Now, that's all we need for distributed method. Distributed no method, something?
Moment distribution.
Yeah, moment distribution factor. Method. You only need 3 things. K, distribution factor, and fixed end moment. So we have all of them. So let's now do the table. So for the table, just erase this. So in our case, we have a fixed point B, C, D, B, C, D, yeah, 3 points. So you're gonna have join 1, 2, 3. I have enough space. Join B, C, and D. Members. Gonna have B8, BC. I should use that. And this one you're gonna have CB, you're gonna have CF, you're gonna have CD, style.
There's the. We're trying to find any more.
CD, you have DC, BC, DE, CF, FC. Because it's fixed and fixed, so we can't just ignore this moment. This one you can ignore it because there's no moment at this point. But this one you have moment, so you will have FC. So now we have the members. Next one, you're gonna put the distribution factor. Which is 0.6, 0.4, 0.25, 0.5, 0.25, 0.4, 0.6, and 0. The reason why the distribution factor for CF and FC is 0 because at this point it touched the ground, so all the force is going to be distributed, so it's 0. That's why you have 0 over there, because it's a fixed support. And for next one, you're going to have fixed end moment. In this case, we're going to have 2, which is BC, negative 150, and CB, 150. And you know we're gonna moment, carry over moment. This one is moment again. Carry over. One time, 2 times, 3 times. So next one, distribute it again, and then just sum them. So let's start looking at point joint B, joint C, and joint D. So for joint B, you have to add up the fixed end moment. In this case, this is 0, nothing here. So 0 plus negative 150, you have negative 150. So you take this number times the distributive factor, you have this number. Negative times this number become positive. So you're going to have 90, this times this, negative become positive. So you're going to have 60. Same thing here. You have to add up the fixed end moment for this, this, and this. But since they are 0, so nothing's there. So just 150. So this times this, you're gonna have negative. Positive times this number becomes negative. It's opposite. So you're gonna have 37.5, negative 75, negative 37.5. And now that's it. You have no fixed end moment, no fixed end moment. So now carry over. BC, CB. So you're gonna have this. This to here divided by 2. So you have 30 here to here divided by 2. You're gonna have negative 18.75. Something here. Wait, not here, not this one. CD, DC. So you're gonna have this to this. Here to here nothing, so you don't have to do it. So negative 18.75. And for CF, you have CF and you have FC. So you carry this. Should I draw it? No. You carry the CF to FC divided by half. So you're gonna have this divided by half. You're gonna get negative 37.5. So do it again.
Could you explain why you just did it at BC and CB and not CF and CD?
Carry over. CB, BC, same span. CD, DC, same span. CF and FC, same span. That's why they carry over. If the moment at this one have nothing to do with this, so you can't carry over AB to ED. They're not related, so you can't do it. But BC and CB, same one. So the moment when you put something here, it's going to affect something here. When you put something here, it's going to affect here too. So that's why you carry over. And for distributed moment, you do the same thing again. You add this, and you take this number times this, the factors. You're going to have, I'm not going to say it anymore, just write down the numbers. So this times this times that, you're going to have negative times this become positive. So you're going to have 7.5, negative 7.5, negative 15, negative 7.5, 7.5, 1.25. Wait. DE. No, I carried it to the wrong table. Should be CF to FC should be right here. I put it in the wrong spot. So you're gonna have negative 37.5. This, that. So. And for this one, you do the carryover again. BA had no BA. You didn't have BA AB, so nothing. This one, just follow the arrow. You have this divided by this divided by 2, so you're gonna have negative 3.75, 3.75, nothing. So you're gonna have 3.75, negative 3.75. And for CF, this is carry over to FC, and you have to divide by 2, so you're going to have negative 7.5. You do it again, this plus this, only this. So this times this equal this, this times this equal to this. So you're gonna have 2.25, 1.5, negative 1.875, negative 3.75, negative 1.875, 1.5, 2.25, so carry over. You see the arrow, you just do the arrow again. And you know the CF is going to go to FC. So for this one, you're going to have negative 0.9375, 0.75, 0.75, negative 0.9375. And you carry over this CF to FC divided by half, divided by 2. So you're going to have negative 1.875. And the last one, you have to distribute it again to get the final answers. So you take this times the factor, you get this times this, you get this. So you're going to have 0.5625, 0.375, negative 0.375, negative 0.75, negative 0.375, 0.375, 0.5625, and 0. And you sum them. You sum everything from this part to this. You sum them and you put it in here. So you're going to have 104.1, negative 104.0, 137.2, negative 94.5, negative 42.8, negative 14.06, 14.1, negative 46.9. So this is your first table for this one. And after that, you have to do another table. And you remove, because this table is when you have a fixed point, I mean not fixed point, but you just make it fixed, so it's not going to move. That's why you only use this low and nothing else, because it's just fixed. You just do this as your stable structure, something like that. But now, we finished the first table. After that, you release this. You know, when some force acting this way, this thing is going to swing like this. Delta 1, delta 2, delta 3. And you know delta 1 is equal to delta 2 and is equal to delta 3. In this case, you have to use, you do the same thing. Step 1, you find the K, and the K is the same as this one. And for distribution factor is also the same. It's not going to change. This is not going to change. The only change is the fixed end moment. So for fixed end moment, you're going to use different formulas, because right now, you only consider this force over here, and it's not a number. You just put a R as a force, and you you cancel all you erase all the force. So you remove the load. Delta 1. You don't have this. So in this case, your fixed end moment is going to change. fixed end moment. Because before fixed end moment, you have distributed load here and nothing else. So you have BC and CB. But in this case, it's going to be different because you have a force, and it's going to create some movement for this point, and this point. So when you use the equation, you have to use this. The table. And you're going to use this or this because it's fixed. And you can see the delta, the change. The rest, you didn't see any change. Only this one and this one. You do the same thing. If it's fixed and fixed, you use this equation. And if it's a fixed and a 4-end pin or roller, you use this equation. Left to right is negative. Right to left is positive. Yeah. Left to right is positive. Right to left is negative. So, in this case, we have a fixed and a 4-end pin. So you're gonna use the the right side one. So which is, and it's from, let me see, this way, no, turning that way. So it's gonna be. The delta is pointing this way, so you're gonna have, it's negative. So you're gonna have FEM BA is equal to be negative 3EI over L squared, which is 3E, the I is Wait, something wrong. Mohammed, can you just stop it for a while?